Okay, today we're going to continue with lines, and this is our last topic of the week. So it's really just the addition method and graphing lines this week. Try to make sure you got it. So, I put a little inequality. If I put inequality, that means there's going to be shading involved, infinity. So, but I start off by just graph the line as like it's an equals. If there's no equals, it's a dash line. So graph like equals. No, if there's equals, it's solid. If there's no equals, it's dashed, meaning it's not part of my graph. It's just a boundary. So it's solved for y, so the y-intercept's -1. The slope is 3, so up 3 over 1, up 3 over 1. No equals, so dashed. Now, one of these sides is true, one side is false. So I shade one side. So what I'm going to do is pick a point in one of the regions. Doesn't matter which one. So either in this region or in this region. So I'm going to pick the point 3, 0. And I'm going to put it in the original inequality. So I'd have 0. Is that greater than 3 times 3 minus 1? Is 0 greater? 0 from here. 3 goes in for x. 9 minus 1. Is 0 greater than 8? No, false. So this is the false side. So this has to be the true side. Now let's pick another point and see if it's true. Let's pick -2, 0. Is 0 greater than -6 minus 1? Is 0 greater than -7? Yes. Let's pick 0, 5 up here. Is 5 greater than 0 minus 1? Is 5 greater than -1? Yes. So, here, 2 is my y-intercept. -1/2, so down 1 over 2, down 1 over 2. There is equals, so it's solid. Now you have to pick a point not on the line, because the line is where it's equals. I want to know where is it less than. So I'm going to pick the origin. 0 less than 0 plus 2. Is 0 smaller than 2? Yes. So I shade 0, 0, because that causes it to be true. Here, 3, 0 causes it to be false, so I shaded the other side. Now here, if it just says graph, and it doesn't say how, when it's in standard form, ax plus by equals c, I do intercepts. So the x-intercept, x equals 4. Y-intercept, 2y equals 4, so y equals 2. Now, is it a solid connection or dash? There's no equals, so it's dashed. Kind of missed a little bit. There we go. Now, let's pick the point 0, 0. It's not on the line. Is 0 plus 0 greater than 4? Is 0 greater than 4? False. So this is the false side, so no shading, so this has to be the true side. So go ahead and try this one on your own and then turn me back on. Okay, so again, if it's in standard form, I like to do intercepts. X-intercept is 3, put 0 in for y. The y-intercept, put 0 in for x, is -2. Now you don't have to, you could solve this for y. Treat it like an equal, solve for y. It is an equal, so it's solid. And I'm going to pick 0, 0, because 0 is nice. 0 minus 0, 0 times 2 is 0, 3 times 0 is 0. Is that greater than or equal to 6? Is 0 greater than or equal to 6? False again. Oh my goodness, I'm getting all these false. But if this is false, everything on this side of the line is false. So the true must be this side. Now, I have more than one inequality, so I'm just going to graph them both and see where it overlaps. So x greater than 2. Yowzer. Now it's dash because there's no equals. Greater than 2 would be this way because the number is 3, 4, 5, 6. Now what they say, you could either color this. Is my pen dying? It looks okay. Draw segments in one direction, so when you draw the other one, y and -3 is horizontal. We do go this way with it, below, smaller. So it has to be right in here. So we just color that in because that's where it overlaps, where you get the checker pattern. So see if you can figure these two on your own and then turn me back on, I'll do it. Okay, so this one, y-intercept's -2, slope is 3, so up 1, 2, 3 over 1, up 3 over 1. Now there's an equal, so it's solid. Now shade before you go on to the next one. So I'm going to put in 0, 0. It's not on the line. So is 0 greater than 0 minus 2? Is 0 greater than -2? Yes. So I'm going to draw. Now I shouldn't go past the line. That's a little boo-boo. Don't do that. Now let's do this one. Y-intercept's 3. Slope is -1. So down 1 over 1, down 1 over 1. It's solid. Whee! I'm going to pick 0, 0 again. Don't have to. Anything not on this line. So is 0 less than 3? It is. So I'm going to shade the side that has the point 0, 0. And then where you get the checky board pattern. Checky board, checky board. Hoo, 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 hoo. So this one. Again, standard form. If I don't have to choose, I'm going to do that. X-intercept 6. 1, 2, 3, 4, 5, 6. Y-intercept 3. Ou, deux, trois. Now, no equals, so it's dashed. Now, let's do 0, 0. Not on the line, so I can do it 0 less than 6. Yes, it is. So I'm going to do this. Now, some people like to color. They see the different colors. So use one color for this one color for this one. So this one, x-intercept is 4. 1, 2, 3, 4. Y-intercept is -4. Okay, 1, 2, 3, 4. It's dashed. Okay. So I'm going to pick 0, 0 again right here. Is 0 minus 0 less than 4? Is 0 less than 4? Well, you bet you're sweet. Something you bet. So the answer, I think we can see the overlap is right in here. Okie doke. So here's the homework. I want you to turn in these 2 pages. Remember, it has to be by Sunday at noon. So I don't know why I boxed it that way, but these 2. Now still do this one. Still do it. But those 2 you need to turn in. And remember, if you only turn in a couple problems, that doesn't count. This past week, I had a bunch of people just turned in 3 problems. That's still 0. Sad to say, but have a good day. Bye-bye.